So a quick recap. This is an example of how the IODD output data maps up in the PLC when we have an integer array. This example and what we'll be looking at today will be in an Allen Bradley PLC. That said, you'll see here that the mapping, whatever PLC we are mapping it to, as long as we are sorting the data into a Word or an integer format, is going to map the exact same way in any PLC. So just a quick reminder, this isn't just a video for Allen Bradley, it's a video for all PLCs. So that all said, let's jump into the Allen Bradley software and we'll get moving forward with modifying the pulse width modulation, turning the channels on and off, and just how the functionality works overall. The simplest way to change our port modes for pulse width modulation is to come into the Mineo software, connect to the hub, and then there's drop downs for each one of these. My instance, I'm just going to keep these first two. These first two ports are the only two ports that do pulse width modulation current output. So we'll just set those up there, and I set up all the rest of them here to do the duty cycle, which is 0 to 100%. It says 1,000, but it's missing the decimal place there. So that said, once you make this change, you hit write to device. That's going to write the modes to the ports on the AL2x05. And the last thing I would mention here is we can, if we wanted to, it'd be more work, but there are IO-link indexes where you can change these port modes through the PLC. That said, that would be through an Acyclic command, and that's going to be more complicated for sure than just simply setting them through the Mineo software. So let's get back over to the PLC and make some changes. Back in the PLC, we can see how the data in array 1 here matches up with that first section of data in the IODD document and how that lines up with digital outputs and turning the pulse width modulation on and off. I've labeled each individual bit actually underneath here. We're going to ignore the digital outputs, and what we'll see here is that bit 10 and bit 11 are a 1, which are turning on the pulse width modulation for port X1.2 and 1.3. Let's minimize that. And then down here we can see that I'm going to put in, to start out with, I'm going to put in 500 and 250. And then we'll see in my oscilloscope that our yellow line is going to be our 50% duty cycle right here for 1.2, and for 1.3 we're looking at a 25% duty cycle. And then we can go through and just make some quick changes. So let's do a 250 to 250, and we'll see that they both overlap. And then we can do a 250 to 500 just as examples. And there we have 25% duty cycle and 50%. And then if we wanted to see a flat line for our duty cycle, we can do 100%. And like that, we can easily change our pulse width modulation. And we have our AL2x05 set up and sending pulse width modulation data. Thank you, and have a good rest of your day.